Hello everyone, welcome to Learn Overflow. In this video, we'll discuss another LeetCode problem, that is the string compression true. This is a hard type problem, and yes, this is really a hard type problem, and we'll understand how we can solve this question easily by understanding the logic behind this question. Okay. So before moving on, if you haven't subscribed to this channel, make sure to subscribe to Learn Overflow for regular LeetCode videos like this. The question says we need to do the run length encoding. And what is the run encoding? It basically means if there's something like A, B, C, 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 we should replace it with something like A2, B, C3. Like if there is A 2 times, so we write A2, then B is 1 time, we don't write it 1. So that is like B, and then C is like 3 times is repeated here. So we write C3. Okay, so that's what that's a run length encoding. And further it says that when there's a one, we don't add one. Like B is only 1 time, so we don't add a one at the end, we just add other numbers at the end. Fine. Now we need to what the question is like we are given a string S and the integer K. Okay, an integer K is given to us, and what exactly we need to do, we need to delete at most K elements, so maximum K elements we can delete. Fine. From this S such that the run length encoding of S has a minimum length. Okay, so we somehow need to minimize the run length encoding. So how we can, like, if we have this as a value for us, right? If we have this one as a value, so how we could have reduced the length? It basically means, say A B C C C, there's 3C. So how we can have reduced the length? Say we have to reduce at most 2 elements. Okay, so at most 2 elements can be reduced if that is the case. Now what could have done, if we have reduced two A's, then the remaining like the remaining length remains BC3, right? That's what remains if we have removed 2A. But if we have removed 2C, like the maximum we can remove 2 elements, right? If we have removed 2C's, then what's the length become? The 2C is removed, but the count of C remains as 1. So the length become A2BC, right? 2C is removed, not 3C is there, there's only 1C. So A2BC, the length becomes 4. Fine. If we have removed that one B and one other element, then it would have also become, say we have removed one B and A, then it would have become A, then C3, right? Something like this. So we can see, like, maximum, after deleting maximum 2 elements, what will happen in this case? The minimum length that we come across is 3. Okay, either 3 in this format or 3 in BC3 this format. Okay, but so this is what we can reach up to. That's the minimum length. So this is the length. Look at the length of the run length encoding after run length encoding. Fine. So we need to return 3 in this case. So this is what the question is asking us to do. Now it says, like, find the minimum length of run length encoded version. Remember, run length encoded version of S. Okay, so that's what we are looking for, the length of this encoded version after deleting at most K characters. So we have to say we have deleted at most K characters. So that means either K number of characters or less than that. Okay. So at most K characters, what's the minimum length remains for us? So that's what we need to look for. Fine. So if that is the case, we need to find it out. Now, what will be our approach to this type of question? Our approach should be, see, if you have done enough of a DP kind of question, you will understand that we are going in kind of a DP kind of manner, right? We see, the first thing is we should be greedy. Okay, we should be greedy in type of like our approach should be greedy in terms of minimizing the length. Okay, just understand this. Okay, later on we discuss the approach. First, let's understand that we should be greedy in minimizing the length. Okay, we should do something to somehow minimize the length to its maximum. Okay, now the problem is, if we have anyway sorted this or anything we have done to it, does it anyway matter to our problem, like matter to our question anyway? No, because it doesn't matter, because we are actually looking into the encoded list. Okay, in an encoded list we are actually coming across 2-3 options or 2-3 pathways to choose from. Either you can see, either you can come up with this path, or you can come up with this path, or you can come up with, like, removing 2C. So removing 2C will remove A2, B, and then C. So this is the encoded string, right? So that's a path you can come up to. Okay, so you somehow come up to a place where we need to do a thing like we need to choose from various choices. Our initial approach was to be greedy in minimizing the length, but we found that being greedy, apart from being greedy, we need to be choosing from multiple solutions, right? Multiple solutions can be possible, so we need to choose from them. So once multiple solutions can be possible, we need to choose the minimum length out of that. So in this kind of scenarios, if, as I say, if you have done enough of dynamic programming solutions, you will see this is a pattern being there. Okay, that you are trying to be greedy, but you have multiple pathways to take, and out of one pathway you will have the your best case solution, right? Or maybe there are multiple pathways leading to the best case solution. So in this type of approaches, here comes as a DP approach. Why? In DP approach, we take a note, we keep a note of this, that with our, like, take a note of all the other approaches, uh, removing one element, whether we are coming across to an best case solution or we are coming to a worst case solution. Okay, so that is our approach, and these are the areas where we use dynamic programming. So what we will do, we will say our approach is something like this. We will first come across this first A. Okay, I'm taking this example one. So we'll come across first A. So our approach will be two: either take this A, okay, keep this A, or delete this A. Fine. If we delete this A, so our number of elements, like the number of elements to be deleted, get reduced by one. Or if we keep this A, then our number of elements to be removed remains as it is. Fine. So this remains same. Fine. Now, what will be the further we will do? Further, what we will see, this is the approach we will keep on doing for rest of the element. We'll either take an element, they keep an element, and continue with the next element, or delete an element. So at each step, we'll do this. So at each character, we'll have a two-path breaking away, and there comes our dynamic programming approach. Okay, so dynamic programming will actually help us to store the solutions. Now, how our solution is bothered? What are the cases where the solution can get deferred? Fine. Say there are like three A's are there right at the beginning. So if I just clear it off, so you can see there is like three A's are there at the beginning. So three A's are there. So you got one A. Okay, your answer, your length got one. Fine. Now you got two A. Your length becomes two. Fine. From like if you got 3A, 4A, 5A, doesn't matter. Your length becomes two as it is. Like your length becomes two as it is. If you have one A only, your length becomes one. If you have two A, your length becomes two. And from 2 till 9, your length remains 2. Like you are looking into the run length encoding, right? Your length remains 2, or length of the string. Then you got 1B. Fine. Okay. Before moving into B, say after 2, like after 9. Okay. Say there are 9 A's repeatedly. Fine. What if there are 10th A after that? So if you got 10th A repeated characters, then what will happen? It will not be 2. It will be, say, 10. 10 will be a 3 length. Like it becomes a 3 length character. So in that place, our length becomes 3. Fine. The other case can be, see, if we have reached 100. Okay. If we have reached something like 100, then like we found 100 A's are there, then our length becomes 4. Fine. And is it possible for further further investigation? See, here you will see that the S dot length, like the total this length, is less than equal to 100. Okay, so like after 100 or after a length of 4, we actually don't need anything to look ahead to. Fine, we actually don't need to see further. So we somehow found that the maximum length followed by a character, like the in our as I say, in our run length encoded version, can be 4. Got it? So our approach will be, if we delete a character, does our length gets reduced or not? Fine. So this is our whole approach, that if we delete a character from this continuous length, if we delete a character, then whether this length reduces or not. Fine. And this is the whole approach we'll go ahead with in solving this question. Now, fine. So here we are with this solution. Let's understand this, how we're going ahead with what we're discussing over here. Fine. So first of all, we took a DP, a 2D DP, and then a cache. This cache or a character array. So this one will store our given string as a character array, so that it becomes faster solution. And further, we'll go ahead with the length of the whole like the whole string, initial string we have, string s. Fine. So that length will be stored in a n. Fine. Now what we're doing over here, see, So in our given function, we have basically two functions, one the given one and the other the dp function. Now what we're doing, we are simply first thing, a few things are like converting our string to a character array, then storing the length of the string in this n, and then initializing our dp array. So dp array initialization is like n cross k plus 1. Okay, so just getting an n cross k plus 1, that is the length of the string and the number of characters we can remove. Fine. Then we are like initializing each of the row like this. We are initializing each of the row as like -1, just initializing them. So this 2D DP array is like we are defining this by starting index of the right subarray and of the each of the choices being k plus 1. Fine. Now we are calling our DP function. Now everything what we do is with our DP function. And this approach or this approach just we discussed just now will be followed step by step. Now there are two base cases in this. What are the base cases? Let's understand. The base case is when our k is less than 0. Our k less than 0, that means how many elements we can remove. Okay, if we find out that the number of elements we can remove is less than 0, is not even 0, then do we need to remove anything? No. Okay, so in that case we simply return n. That is whatever the current length, it will be like the current length we come across, it will be our length. Fine. Or there is another like but remember this n over here is actually we are finding out in terms of the compressed length. Okay, we'll discuss about that. Since this outside, don't confuse it with that because in the next computation it will be changed. So that's how I just made sure that you don't confuse that with that. So further, if we're checking that this so this particular check is like we got n is less than equal to I plus k. That means what is the current I? Current I is 0. So what, if it is our like whichever current element or ith element we're trying to remove or delete, if that current element plus our k, okay, is greater than our n, right? So like if we find that it is like going greater, that means that can we have two cases. One, we have deleted like one can when it is like when k is 0, then we have like deleted all the possibilities and there's no point deleting further. Fine, that is like all done for us, or the other case is all deleted for us. Okay, so that is the case when this should come across, when this I plus k, this current element plus our number of elements to be deleted will become greater than equal to n. So there is like two elements of like either like we have deleted everything or we are all done with this. Further steps are done, so I'm simply returning 0 for further calculations. Then here comes the interesting part. So these two are the base conditions. You will understand this when we deep dive into it further. Okay, now this base conditions, let's see. First thing is we are what we're doing, we are taking the ith and the kth value, kind of like whatever the previous value. So you know you initialize this as -1. So we're taking something that being the our answer initially. Fine, that being our answer, that this is the current answer we are going to look for. Fine. So initially you will find this is to be -1, but in case this is not -1, that means we actually got some value which is being stored over there. Fine. If we found some value, that means it's not -1. So if it's not -1, we'll return answer. Okay. So that's being we are like use this DP to save the steps. Fine. We're just using that, like if it is previously computed or that ith position value is previously computed somewhere, we're just saving this. Now coming to the next part, that is over here, what we're doing here. So answer is dp of I plus 1 k minus 1. We're just moving to the next element at k minus 1, that is we are just removing an element. That's why as I said now, we will remove once we remove an element, we'll make k minus 1. So what happened if we have computed previously, our answers is returned. Or if we have not computed, then we have two choices. As I said, one will be to delete the ith character. So this step over here is considering the delete of the ith character. Okay, we are moving to the next character and considering that this character is deleted, so we make the total number of deletions to be made further being -1. Fine. Now there are three. So one we got like deleting this current character. The next thing we'll do is like taking this correct character or considering this, or like if we don't delete this ith character. So now the next part will be there. So if we don't delete this current character, so first we got the length. Length being what is the total length of our array. Okay, it's like total length of our this one, like the run length encoded version. So initially, initially 0 is there, so initially we are taking 0. And now the next thing is same. So with the same function, the same variable, we are storing how many characters we got same. And then we got another character like the difference. It's like how many character difference we find. Okay, if there's a difference we find, that means we need to change the value, right? So that's the difference we are finding. Now what happened is like we start from this ith element or the current element and go till our n, like a total length. Fine. Initially I is 0, so we start from I till the length, and in that we got like we'll check that the difference should be less than equal to k. If our number of different element is going more than k, then we know that there are like uh, n like k number of different elements are there, so we can easily remove those k number of different elements, right? So that's the idea. So if it's going beyond different, then there's no point going further, right? So in over here we are just traversing through the whole length one by one, from a current character to the last character, and finding out if we find two characters being same, which initially, see, j is equal to I, so char of j and char of I both will be same in the first case. So in the first case we find this is same, so our number of same characters becomes 1. Same was 0, so same becomes 1. Now same becomes 1. What we are checking, if same less than equal to 2, we are increasing the length. Why? We are increasing length becomes 1. Why? Because if we got a being a character, fine, we are checking a equals a, this particular character. We found how many same values are there. 1 same values are there, and the length or the run length in encoded version becomes 1, right? That's the length. Then what we are doing, if we find another same character, okay, the same becomes 2 and the length becomes 2, fine. But the thing will change further. If we find another length same character, the same becomes 3, right? But the length doesn't become, because the run length encoded version will be a3, which I was discussing. So that's why you find only less than equal to 2 is there, we will increase the length. Or if it reaches 10, that means we find 10 values, so our encoded version will be a10. Okay, if it reaches 10, then only we'll increase our length to be 3. See, a10 is a 3 length character, so that's why we just increase it to 3. Then if we find a difference in the character, if we find a difference, then what? We are increasing our difference, like how many different characters are there. Now further we are finding out the important thing. The important thing is like, first of all, we find this answer being if we have deleted that particular character, ith character, if we deleted that, and then we found a length if we have included this particular character, fine. That is, this is the total length we are reaching. Now with that, with the length, we are adding what? dp of j plus 1. J plus 1 means whichever character we are at last, so the next character, and k minus difference. So how many different characters we have found, so we just reduce that from our current k, like the current number of characters we're supposed to remove, fine. So we just remove those. So what will happen, this will return us what exactly? It will return us the better, or like we didn't return as a result, or actually we're doing the minimum of that. So this will return as a result to understand whether it is better to delete that or to take that. What is the current status? If we delete that, if we delete that, is it the minimum length? Or if we have taken that element and went into the next element, so which one gives us a minimum length? Fine. And we store our minimum length in our dp of ij. Fine. Here is the stored minimum length. Now this storage will somehow get reflected over here after when multiple calls are made. Then if we have already found a value of dp of ij, we are stopping this further calculation over here. So that's why I said these are the steps given over here. Now we are doing something like over here. See, dp of j plus 1 and j plus 1. Remember, j is going somewhere till n, like less than n. Fine. If j has reached less than n, that is j, say j equal to n minus 1. So this is the maximum character that j can reach. Okay, and j plus 1 becomes n itself, and we're doing k minus difference. So what if k minus difference is k itself? What if we didn't find any difference? What I mean is like say in the last example, there you don't find any difference, right? K is 0 though, but say k is 1. and we don't find any difference. So k minus difference remains to be something what we're looking for. Okay, so say k is the value and we reached j plus 1, that is n, and k minus difference remains k, like we are considering k, difference to be 0. Okay, let's consider a case like that. So what happens in that case, you will find those base cases are involved. Those base cases, now you will see j plus 1 is there, which is n itself is getting passed, plus k, some value is there. So n plus some value is always will be greater than equal to n, right? In that case, we'll return 0. That there's no point going further, right? We are all done with it, right? So we have just accessed our value and there's no point going further. Like either we couldn't find a end, okay? It simply means we have found the end to it, or we are all done with it, fine? So as I said, you will understand this base cases further when I explain it again. Now, ultimately we're storing it, using taking help of our DP and returning our final answer. Fine. So this is the whole process in understanding this question. So I hope I can make you understand how you can solve this question and how you can actually find a better solution. Now, as I just wrote this question and as I show you usually every day the how this question works and all. So let me just quickly show this, like run this code. Since I didn't run it to show you, let's just quickly run this code and here you will see. Okay, and let me submit it. We will see it further. Fine. So this is like it shows me 24 seconds, but obviously a few minutes back when I was trying it was showing me 22 seconds. And this is kind of the fastest solution you can come across, right? Obviously, this LeetCode is have its own judgment at times. But yeah, as you can see, it's like 22, 23, 24 varies. Anyways, this is kind of the fastest solution you can come across. So I hope I can make you understand how we can solve this question easily. Okay, so if you have any doubts remaining, make sure to comment them down in the comments as well. I'll be happy to help you out. Also, subscribe to this channel for regular LeetCode videos like this. Thank you all for watching this video. Hope to see you soon in my next video as well. Thank you.